Yeah, I like now to introduce John McNeill from the keynote speaker. He is from Georgetown University. He's a world historian, you may call him, but he is an expert, particularly in what is called environmental history or ecological history. It's perhaps good to mention that in 2018, I think he received the Heineken Prize, accorded by the Royal Netherlands Academy of Sciences, of Arts and Sciences. So actually, from here, 4 years ago. He wrote, well, a number of important books. I mention only one of those books, which I read myself, namely the Human Web, which he wrote with his father, William McNeill, the great pioneer in world history. And I also want to say that Joop Goudsblom admired the work of both William McNeill and John McNeill. So we are very happy that you will give this lecture now with a very intriguing title. So please, John McNeill, may I give you the floor?
Yes, thank you very much. And let me say thank you to the organizers for inviting me. I am an admirer of Goudsblom's work, and I have been since I was first introduced to it by my father in the 1990s. I'm going to share my screen with you now. All right, I hope you're seeing an introductory slide with my title, Bison, Elephants, and Whales on it. So the first thing that I will do is say a tiny bit about Goudsblom. And then go on to explain that what I'm speaking about today is taken from what I hope will be my next scholarly book, and I'll explain a little bit about that book. Then I'll explain two concepts that are in this talk. One of them is very familiar to most of you, I think. One of them might be new to you. And then I'll visit three examples: bison, sperm whales, and East African elephants. And in doing so, I'm going to include what I call a Goudsblom adjustment to my normal approach to these matters, which means a deeper history, attention to longer term socio-ecological processes. So I was first introduced to Goudsblom's work by my father, who admired that work and admired Goudsblom as a person. I met Joop for the first time in Amsterdam, 1996. I remember the occasion quite well. And I met him several other times in Amsterdam and once in Leiden. I don't think ever outside his native country. It was what I call late Goudsblom that was congenial to me. The Goudsblom of Fire and Civilization, the Goudsblom of Mappai Mundi. His earlier cycles of work, figurational sociology, I have to admit, I have not come to grips with. One last thing I want to say about Goudsblom is that he and my father maintained an old-fashioned correspondence for many years in the 80s, the 90s, and the early 2000s. They wrote dozens of letters, long letters, mini essays, trying out ideas on one another. And if anybody's interested in this paper trail, which says something about Goudsblom's intellectual odyssey in those decades, the raw material is in the University of Chicago Library. Okay, Let me get on with my talk. I'll try to bring it in under 30 minutes. I know we're a little bit behind schedule today. So this is the plan of the book that I have in mind, A Global Environmental History of the Industrial Revolution, or of industrialization as a process. I see it in three parts. One about the industrial heartlands themselves, a second part, more interesting to me, about what I call ecological teleconnections. That's one of the two concepts that I intend to explain shortly. And a third part that concerns contemporary industrialization of East Asia. And today I'll be doing these fragments, one about bison hide, one about elephant tusks, and one about sperm whale oil. So these are the segments of the larger book. What I'm hoping to do in the larger book is, as I put it here, to ecologize the Industrial Revolution. As far as I know, ecologize is not a word, but it should be a word. I want to convince my fellow historians and the general public that the Industrial Revolution should be understood not just as a social and economic transformation, but from the very beginning, an ecological transformation, and that it should be understood from the very beginning as a global phenomenon, not merely one involving Britain. That's what I'm up to in the larger project. The part of the larger project that I'm really interested in, part two, is about ecological teleconnections. This is a term that I use to refer to impacts thousands of kilometers away that industrialization had on fields, plantations, mines, fishing grounds in the four corners of the world. And one example of this depicted here that I'm going to speak about in greater detail in a moment is textile factories in Eastern North America and in Britain, and the Great Plains of North America. The textile factories needed what they called machine leather for transmission belting. You can see that pictured here. And it turns out that bison leather was better than cattle leather for this particular purpose. And this was among the several causes for the near extinction of the North American bison. This was, according to evidence provided by a few Great Plains historians, the single most important reason of those several reasons for the near extinction of this animal. So that's an example of a ecological teleconnection. And that is the key concept, the central concept behind this work and this talk. Okay. Second concept is one that most of you are quite familiar with. Many of you know a great deal more about biology and ecology than I do. The concept is that of keystone species, species that help to organize and regulate the environments in which they live. And I'll mention some of the specifics concerning bison, elephants, and whales when I get to them. Although in this one picture up here, bison is performing tasks suited to a keystone species. It's doing what we call in North America snow plowing, which makes trails through deep snow that other creatures, particularly pronghorn antelope, exploit, and it helps keep pronghorn alive in snowy winters on the Great Plains. So, two simple concepts. The first example, the bison. In the first half of the 19th century, there were probably around 25 million bison on the North American Great Plains. Estimates range up to 40 million, but I think the most careful work nowadays settles on around 25 million. Bison had been in this landscape, which I propose to call the bison steppe, sort of homage to the mammoth steppe of Eurasia, for about 150,000 years. In the longer term, going back millions of years, this steppe land in the center of North America was inhabited by a variety of grazing animals, including horses or proto-horses that had been there for several million years. The bison joined them. They were immigrants from Eurasia, as I say, roughly 150,000 years ago. And thereafter, they shared the steppe, the grasslands, with this menagerie of species, almost all of which are now extinct because of the so-called late Pleistocene extinctions, which may have been the work of human beings, perhaps in conjunction with climate change, perhaps in conjunction with some transmissible diseases. There are a variety of hypotheses to explain the late Pleistocene extinction. And the horses disappeared from North America, and many other big animals too, leaving empty niche space that the bison charged into. So that by about 11,000 years ago, this steppe was much less diverse in its megafauna and was essentially a, well, as Dan Flores calls it, a faunal monoculture of bison. And the extent of that bison steppe grew over time once humans entered the picture, roughly 13,000 years ago. Humans arrived earlier in North America, but on the grasslands only about 13,000 years ago, as best we can tell. And through their use of fire, one of Goudsblom's favorite subjects, they expanded the range of bison by expanding the grasslands. And they hunted bison, but on a very small scale because the technologies were not all that well suited to bison hunting until horses returned to North America. So this is how bison got there, and this is why there were so many bison, maybe 25 million in the early 19th century. Horses came home to their land of origin, Central North America, after an 11,000 year absence. They had left millions of years ago to Eurasia, gradually moving westward with human help to Iberia, and from Iberia entered Mexico in 1519 and the Great Plains after 1680. So by 1700, wild horses were flooding into the Great Plains, and the equestrian arts, riding horses, managing horses, breeding horses, were quickly mastered by some of the Amerindian peoples whom we call in North America the Plains Indians. And various of the Plains Indians migrated from the edges of the bison steppe into its center once they had mastered the equestrian arts, including the Lakota, Cheyenne, Comanche, and Kiowa. So by the middle of the 18th century, these peoples had created a new culture, an equestrian culture, a horse culture, and it included newly efficient bison hunting done from horseback, as indicated in this painting by George Catlin And you can see in these maps something of the range of the bison as of 1700. And as it shrank, this is 1870, 1880, and 1884. And that process of shrinking range of the bison and depletion of the bison had begun, it now seems, as early as about 1790 because of the increased efficiency of hunting from horseback, and because horses themselves competed with the bison for the energy in the grass. Maybe 2 million wild horses and another 100,000 domesticated horses were nibbling away on the Great Plains and eating into the food supply of bison. That slow decline from 1790 accelerated in the early 19th century. Drought was probably part of the equation. There were serious droughts on the Great Plains in the middle of the 19th century, especially 1856 to 64. But they weren't spectacular droughts when seen against the long-term pattern of drought in the Great Plains of North America. So by themselves, the droughts, I think, can't explain all that much. There might have been zoonoses, animal diseases that contributed to the decline of the bison. There's no actual evidence for that, but it's plausible. But the biggest part of the equation, without doubt, is market hunting for new markets for bison products. And in the northern Great Plains, that product, the main product was pemmican, which is squished together bison meat, bison fat, and berries. It's a storable food, a transportable food that was important in the fur trade of Canada. Everywhere, the bison robes, their hides, were a marketable product. And what's crucial for the catastrophic phase of bison decline after the American Civil War is, as I said earlier, transmission belts, the so-called machine leather used in textile factories to power looms and other machinery. The railroads in the United States made the connections between the plains and the textile mills cheaper, faster, and more efficient. And white hunters, many of them veterans of the American Civil War, flooded out onto the Great Plains after 1865, killing bison in their millions. But interestingly, the Canadian herd disappeared at the same time without railroads, because there were no railroads onto the Canadian Great Plains until 1885, and without white hunters. The hunters in Canada were either First Nations, that is Amerindians, or Métis, and that means population of mixed ancestry, French and Amerindian. At any rate, the bison population declined from about 25 million to about 1,000 as of 1881. And the keystone species of the Great Plains was almost gone, and a keystone component of Plains Indians culture was gone. So, looking at the ecological side of this briefly, without 25 million bison, what happens to the ecosystems of the Great Plains? First of all, snowy winters get much more dangerous to other animals because the bison are no longer creating trails and clearing snow off of vegetation. Secondly, dry summers become more dangerous because the bison are no longer available to create what are called bison wallows, basically depressions in the landscape that accumulate water. Other animals don't do this. Cattle do not do this. Only bison do this on the Great Plains. and perhaps of lesser significance, except the people who like birds. Birds lost some of their nesting materials. They used bison fur often, and some small species like prairie dogs struggled in the absence of bison disturbed landscapes, because prairie dogs like to make their burrows in landscapes inhabited by bison. And on the botanical side, bison played a significant role in seed dispersal on the plains. And of course, without the bison, seed dispersal had to follow other routes. So human culture changed in the absence of the bison, and the ecosystems of the plains changed in the absence of the bison, because they were a keystone species. It's less obvious that sperm whales were a keystone species, although there are marine biologists who make that case, and I'm happy to accept that case. So this is my second example. Whales waded into the oceans. They're descended from land mammals, land mammals, about 50 million years ago. And the first sort of discernible proto-sperm whales existed by about 25 million years ago. And like humans, sperm whales of today are the last survivors of a genus that was once much more diverse. Today's sperm whales are the largest predators on Earth. They are the loudest animals on Earth, and they have the biggest brains in the history of life on Earth. They eat a lot of things, but they get a large share of their nutrition from squid, including giant squid, which live primarily in the depths of the oceans. And you can see in this map a modern distribution of sperm whale sightings. They're found in all the oceans, but primarily in the middle and temperate latitudes, not in the very high latitudes. And this cartoon is whales celebrating the first hard rock drilling of petroleum, which took place in Pennsylvania in 1859. Humans and sperm whales, humans had no impact, no discernible impact on sperm whales until after 1800, and sperm whales had no discernible impact on humans either until after 1800. At that point, 1800, there are somewhere between 1 and 2 million sperm whales in the world. The latest estimates, which are based on genetic data, tend towards a lower number, around 1.1 or 1.2 million. But that's guesswork. Sperm whales have in their head a wax, which is, when melted down, called an oil. And it turns out to be, to the misfortune of sperm whales, an extremely good lubricant. In the 19th century, it was used also as an illuminant, as a fuel for lamps, but its main use for many decades was as a lubricant in fine machinery, in precision machine tools, in clocks, watches, sewing machines, guns, etc. It was used also as a component of other things, most surprisingly to me, in automatic transmission fluid in cars in the United States up until 1973. The virtue of sperm whales oil is that it's got very low viscosity under high heat. It works well. In cold conditions, it works well, all of which is to the misfortune of sperm whales because it inspired a sustained whale hunt, which was spearheaded by American whalers. Probably did 80 to 90% of the 19th century's reduction in sperm whale populations. And you can see in this graph that it peaked in the 1830s and 40s. It was already in decline when the first petroleum strikes took place in 1859 and continued to decline through the 19th century. But there was a renewed sperm whale hunt after the Second World War on an even larger scale that I will not be talking about. That decline that you just saw in that graph is a decline in the catch. There's also a decline in the rate in which sperm whales were sighted as recorded in the log books of whalers. And that decline is 60% between 1830 and 1850. But the specialists think that the sperm whale populations declined only about 30% in the 19th century. If that's true, the discrepancy is explained by the fact, or at least supposed fact, that whales learned to avoid whalers and they found ways to hide. So they were sighted less often, even if they were not 60% less numerous as a result of whale hunting. And it's probably also the case that the social structure of sperm whale populations was sufficiently fractured by whaling that their fertility declined as well as their mortality increasing. So what happens if you take 30% of the sperm whales out of the oceans? Well, what the marine biologists call the whale pump lost some of its effectiveness. So the whale pump is a term which refers to the habits of whales of retrieving nutrients from below the surface of the ocean and bringing them up to the surface. And as they excrete, they fertilize the ocean, particularly with nitrogen, phosphorus, iron, which are key limiting nutrients. Sperm whales do this more efficiently than other whales because they dive deeper. When they go after a giant squid, they go as much as 7 kilometers below the surface of the sea, and they bring those nutrients up to the surface. So if the sperm whales are not doing the job, then more nutrients are lost forever to the seafloor and never returned to the biosphere except through tectonic processes, which take millions of years. So that is the whale pump, and a consequence of its effectiveness diminished as a consequence of whaling. And this applies not only to sperm whales, it applies to all whales. Part 3, elephants. So the earliest elephant fossils or proto-elephant fossils are from Africa. The genus to which East African elephants belong has been around for about 4 million years. It too, like the sperm whales and like humans, is a genus that has been thinned out over time. There are 2 or 3 elephant species left on Earth. There's some controversy as to whether it should be understood as 2 or 3. There may have been 200 years ago as many as 26 million elephants in Africa. Again, it's guesswork. Why so many elephants? The story is very different from bison. First of all, like all wildlife, elephants in Africa had a very long time to adjust to the emergence of intelligent tool wielding or weapon wielding and collaborative hunters, i.e. humans. The humans did not come as a surprise as they did in North America all of a sudden. The elephants had maybe 200,000 years to learn to live with humans and to stay away. So there's no late Pleistocene extinctions equivalent in Africa. The second reason there's so many elephants is because of tsetse fly and the trypanosomiasis infection that the tsetse fly carries, which is dangerous to most forms of livestock, cattle, horses, so that the East African savanna did not become exclusively grazing land for domesticated creatures. Instead, significant parts of it became de facto wildlife reserves maintained by the tsetse fly and Nagana, to use the Zulu word that's typically used for the trypanosomiasis infection. East African elephants have big tusks. They have the best tusks for working in ivory. Their tusks are a double-edged sword for the elephants. They're very useful, but in recent centuries have become, in effect, an Achilles heel, the crucial weakness, because it's what inspires humans in modern history to hunt elephants. And interestingly, in East Africa now, elephants appear to be evolving into tuskless creatures under the selection pressure of hunting. The risk to elephants increased dramatically with industrialization, and that's the story I want to tell. And it involves a town in the state of Connecticut, which used to be called Ivoryton. It's now called Essex. It's on the Connecticut River. Early in the 19th century, a Connecticut Yankee invented a saw that was capable of slicing ivory into very thin layers. And I'll show you a picture of one of those in just a moment. And East African elephant ivory was the best ivory for this saw. It's also judged to be more lustrous and attractive by people who are connoisseurs of ivory. And so in Connecticut, thanks to this particular saw, an ivory industry grew up, making combs and billiard balls and cutlery, but specializing above all else in the veneer of piano keys. And in the 19th century, this may be part of the civilizing process, every Victorian middle-class household wanted to have a piano in its parlor. Every brothel in New Orleans wanted to have a piano. And the global population of pianos increased dramatically. And about half of those pianos after, I think, about 1860 were made, half of the keyboards were made in the United States because of the location of the ivory industry in the Connecticut River Valley. And there's one town, Ivorytown, imported 90% of all ivory imported into the United States and played a significant role in the story of East African elephant depletion. There's some sources that suggest that roughly half of all African ivory exports between 1840 and 1914 went to the town of Ivoryton. The trade came to an end when plastic replaced ivory as the preferred veneer for keyboards. So here you can see how thin the ivory is sliced on a piano. This piano was made in 1912, belongs to one of my neighbors here in Washington. Quickly back to East Africa. This is just to remind you of the variability of the East African savanna. It's a bit of a patchwork, not all grass, and the grassland composition is variable. The hunt accelerated after 1840. This is evident in textual data collected in consular offices in Zanzibar. And ingeniously, it's also evident in the work of some chemists who have collected ivory objects. No, they haven't collected the objects. They have collected tiny samples from ivory objects in museums in Europe and North America and subjected those tiny samples to isotopic analysis. And what they are able to show is that the provenance of the elephants whose tusks provided the ivory for these museum objects moved westward over time, because the ivory has isotopic signatures in it of carbon, nitrogen, and strontium, and those can be matched with soil chemistry from all over East Africa. And what that shows is a gradual decline in the elephant populations, particularly along the coast. These maps provide, based on different sources, approximately the same story. And the important thing I want to draw your attention to is the dotted area here in the 1890 map, and how much larger it is than the dotted area here in the 1840 map. And the best guesses seem to be that the East African elephant population declined by about half in the 19th century. It's declined much more in the 20th century, down from maybe 10 million in 1900 to maybe 400,000 at the moment. But it declined from probably maybe as much as 20 million down to 10 million. No, excuse me, let me rephrase that. The total population of elephants in the continent of Africa declined from upwards of 20 million down to 10 million between 1800 and 1900. But a large part of that was in East Africa, the rest of it mainly in Southern Africa. So what happens when you take half the elephants out of an ecosystem? Lots of things happen, because elephants are very pronouncedly a keystone species. So on this list of consequences, I want to draw your attention to this here. This is what affects humans most of all. Fewer elephants, more bush, more tsetse fly, more trypanosomiasis, which affects not only livestock, but humans in the form of sleeping sickness, makes it more dangerous to live on the savanna. And there are various features of the reduction in elephant population that parallel the reduction in bison population, which I've listed down here: maintaining trails, maintaining water holes, seed dispersal, all of which both elephants and bison perform. So lots of things happen when you take the elephants out of ecosystems. And I'm about to conclude here with an elephant having a snack. They like the roots of acacia trees. And I'm going to leave you with lingering questions about the larger project here. So it concerns a transition from what's not necessarily an agrarian regime to an industrial regime. That it might be agrarian in some settings, but in the Great Plains of North America, in the savanna of East Africa, in the high seas where the sperm whales live, it's not really an agrarian regime, something else. Maybe a hunting and foraging regime, or maybe something else altogether. But at any rate, under the pressures of industrialization, vast ecological consequences result, or so I maintain. Questions: am I using the right commodities or ingredients? I've got a few other candidates that I might want to include. One that's relevant to Dutch history is gutta percha from trees in Indonesia, which I probably will include in this story. Can I do justice not only to the industrialization of Eastern North America and Britain, but to continental Europe, Russia, and Japan, if they did indeed have ecological teleconnections, which I'm pretty sure they did? And should I really include the part 3 on the current ongoing industrialization? I think I probably will. These are some of the questions that linger in my mind that I haven't resolved. This is very much a work in progress. I'd appreciate any advice that you might have for me. And I hope that, hope that you found it interesting and are still awake, even though it's late in the day in Amsterdam. Thank you very much.
Thank you very much, John McNeill, for this very instructive lecture. I think we all learned a lot from what you just said. May I ask anyone to give comments or ask questions, please? Who wants to start? Well, perhaps everyone wants to think about what you just said, so perhaps it's difficult to ask a specific question. Well, may I start then? Okay. I start with what you said at the end, namely that it's difficult to order what you said in the well-known model of 3 stages, let's say, in human history: hunting, gathering, then agrarian, and then industrial. So what I gather from your lecture actually was that hunting was very important for industrialization. So that makes that clean 3 model of those stages problematic. Is that would you agree with that?
I would say that a simplistic rendering of those 3 stages is definitely problematic. But in Goudsblom's work and in the work of others, it's clear enough, I think, that these regimes, when a new one emerges, it does not obliterate the one that preceded it. It adds new features upon what pre-existed, so that when an agrarian regime emerges in world history, it's not as if hunting and foraging disappears. It's only that hunting and foraging accounts for less and less of the human experience as time goes on, but it survives until today, even though only marginally. So I don't think that these stories that I'm highlighting here, even though they do emphasize the significance of hunting to industrialization, I don't think they make the 3 regime macro vision problematic. Only a simplistic version of the 3 regime vision is problematic.
Clear. Well, I think now, yeah, I give you now the microphone.
Heimo Schulzmein, University of Hanover, Germany. Thank you, Mr. McNeill, for this very interesting insights. Would you think that this Keystone species hunting have, in the broader sense, contributed to the bad image of hunting, especially in Europe? That probably has some links with the memories of the last 4 generations, which you have been covering. Did you understand my question?
Yes, I do understand. And the first part of my answer has to be that I don't know. I don't know what may have contributed to the negative image of hunting in Europe. I expect almost everybody on this Zoom call is better positioned than I to answer that question. But insofar as negative image of hunting in Europe is connected to African wildlife, then I would guess that the answer is a partial yes. But presumably there are lots of other things that have gone on within Europe itself connected to hunting that contribute to this negative impression.
Yeah. Yeah. Thank you. Okay, someone else. Okay, I have to move. Nina Bauer.
Hi, thank you for this talk. It's like personal interest because you hinted on the sugar, and my question would be: would you look at sugar as a food resource for the large animals, or how there is competition between sugar plantations and living space? Just asking because from what I've seen in parts of Asia, that if you have large mammals, they might actually not care about farming lands so much.
So if I include sugar in this project of mine, it would be in the following way. Industrialization had many ingredients, as I call them, some of them lubricants like whale oil, some of them fibers like wool or silk or cotton, some of them ores like copper or lead. But maybe I should also include in this general category of ingredients the calories that went into workers, because industrialization not only required these material ingredients, that it also required labor, and labor required sustenance, and that included sustenance gathered from the 4 corners of the earth, including grain from the wheat frontiers, and including, as the anthropologist Sidney Mintz made famous, sugar from the plantations of the Caribbean and Brazil. So maybe I should include sugar in this way as a component of industrialization. I haven't made up my mind. I'm a little bit hesitant to do that. I think I have enough interesting stories to tell about fibers, ores, and lubricants, but I'm still exploring this general topic.
Someone else. Yes.
Thank you very much, David Sierra from Grenoble University. In the WWF report on deforestation, it is written that indigenous peoples they contribute to stop deforestation. So in a way, they are somehow a keystone culture in stopping this at least it is, they are seen as one of a keystone culture to stop deforestation in some places like in Colombia or in Brazil. And you're working with the rubber. I saw you listed rubber. Are you trying? Do you have in mind to see the genocide that came by because of the exploitation of rubber of indigenous peoples in the Amazon during the first half of the 20th century?
If I include rubber, which is uncertain, and the reason it's uncertain is because most of that story comes in the early 20th century, and for various reasons, I'm hoping to keep this book mainly in the 19th century. But if I do include rubber, then I will be including what I would call broadly the social impact of rubber exploitation, just as when I write about the depletion of the bison on the North American Great Plains, I will also discuss what that meant for the human inhabitants of the Great Plains, which was mainly the elimination of their major food supply. Even though those people, Plains Indians, were not checking deforestation, they were actually contributing to deforestation by their use of fire. But nonetheless, the ecological impact and the social impact of the depletion of the bison or the depletion of East African elephants or the production of silk in Lebanon, any of these stories, they'll all have important social aspects as well. Even though today I've concentrated on the ecological aspects, and in the book I expect to highlight the ecological, but I must not fail to include the social.
Okay, thank you. Well, there's time for one final question.
How about Marina? She has her hand up.
Huh? Oh, online. There is a question online.
Marina Fischer-Kowalski.
Where can we find it? Oh, there is someone. Okay. This is a higher technique for me.
Oh, may I?
Well, wait a moment. Yes. Okay, go ahead. Please.
Okay. Hi, John.
Hello, Marina.
One paradoxical question. If you continued your storyline into the 20th century and maybe 21st, might you come up with the conclusion that the use of fossil fuels was incredibly beneficial for the survival of many natural species on Earth because it offered substitutes without killing them? Would that be a possible conclusion?
It would be a possible conclusion, but against that, fossil fuels contributed to the increased efficiency in sperm whale hunting. They reduced the demand for sperm whale oil as a lubricant, but they made it a whole lot easier to hunt all kinds of whales.
Right.
And plastic being a petroleum derivative meant that East African elephant ivory was no longer in demand for veneer for piano keys after the early 1950s. But at the same time, connections made cheaper and more regular by petroleum created new markets for East African ivory products, first and foremost in China, which is by far the biggest destination for African ivory nowadays. So while in some ways petroleum had the promise of saving some species from further depletion and brushes with extinction, through different channels, petroleum had a countervailing effect.
Mhm. Okay, thanks.
Okay.
But you know what, Marina? I hadn't quite thought of that before you brought it up. I'm going to make some notes after this, because even though I don't intend to handle the 20th century in detail, I think that's an interesting observation that I would like to include.
Well, thanks.
Okay.
Great talking to you, Marina.
Okay.
Long time no see, John.
Yes.
Okay, well, we have to finish here. Thank you very much for this wonderful lecture and this discussion. I think this is a very good end of the second day of the conference. Thank you very much.
Thank you all.
Okay, now, more nice end of the.